In the last video, we explored how to fit logit and probit models for the binary response. In this video, we will look at the post-estimation test statistics and how to obtain marginal effects of the explanatory variables on the outcome variable using the post-estimation commands. Let's open the National Longitudinal Survey of Women dataset. As in the last video, we run a logit regression of union on wage, marital status, whether living in the South, whether living in a central city, and the industry diamonds. The output provides us with some diagnostic statistics. The LR chi-square statistic is for the overall significance test. It is statistically significant in our model. Below that is the pseudo R-squared. It compares the log likelihood function for the estimate model to the log likelihood function in the model with only an intercept. Usually, it is less important than the significance of the coefficient estimates. A diagnostic statistic of the explanatory power is the classification table. We use the estat command to create a table. It shows the correct predictions and the false predictions. In our case, we correctly predict 76% of the observations. Notice that the classification result depends on the cut value. We can change the cut value. We usually use 0.5 or the sample mean as the cut value. In our sample, the mean probability is around 0.25. The percentage of the correct predictions drops to 64%. Let's turn to the marginal effects. There are two types of marginal effects. The first one is the average marginal effect. It computes the marginal effect for each observation and then averages them across the sample. Another is the marginal effect at the mean, which computes the marginal effect at the mean values of the explanatory variables. The dydx option produces marginal effects. We calculate the marginal effects for the three specifications: the linear probability model, the logit model, and the probit model. First, after running the linear probability model, we type margins, comma, and dydx. Inside the parentheses, we put the variables we want to compute the marginal effects. The post option allows us to post the marginal effects as the estimation results and store the results with the estimates store command. In the linear probability model, the marginal effects are the same as the coefficient estimates. We compute the marginal effects for the logit model and the probit model. Then we use the estimates table command to list all the marginal effects for the three specifications. The marginal effects are close to each other. $1 more in hourly wages increases the probability of becoming a union member by around 0.6 percentage points. Living in the South reduces the likelihood of joining the union by 12 percentage points. Living in central cities leads to an 8 percentage points increase in the probability of the worker being a union member. These are the average marginal effects. Keep in mind that in probit and logit models, the marginal effects are different at different points due to the nonlinear transformation from the explanatory variables to the outcome variable. To calculate the marginal effect at the mean values of the explanatory variables, we use the add means option. The results are close to the average marginal effects. Finally, let's export the marginal effects. I have a previous video on presenting estimates. Check it out if you are interested. Here we export the marginal effects to LaTeX. We use the esttab command with various options. We can specify the book tabs option and load the LaTeX book tabs package. A further improvement is to load LaTeX d-column package and format the columns using the d specifier.